Hey everyone, so in this video I'd like to introduce you to the quadratic formula. So we've talked in the past about how to solve a quadratic equation using a couple of methods. For example, factoring is a fairly common method to solve a quadratic equation. But there are some quadratic equations that actually cannot be solved using the method of factoring or some of the other methods that we discussed. So the quadratic formula is going to be fairly useful because it will be a method that will allow us to solve any quadratic equation. So what we have here is, as it says, if ax squared plus bx plus c equal to 0 has solutions, then the solutions will be x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. So notice at the beginning of that sentence, we have ax squared plus bx plus c equals to 0. Well, what that is a quadratic equation. That's a general quadratic equation in standard form. And down below, we have x equals negative b plus or minus the square root of b squared minus 4ac over 2a. What that is actually the quadratic formula. Now, in the quadratic formula, you're going to notice that there's a whole bunch of letters a, b, and c. Those a's, b's, and c's are going to come from the a, b, and c that occur in the original quadratic equation. So when we have ax squared plus bx plus c, the a, the b, and the c are going to be the coefficients of each term. So the x squared term will have a coefficient of a, the x term will have a coefficient of b, and then we have that last constant term, which is a coefficient of c. Those are the numbers that are going to be placed into the quadratic formula. Okay, so what we should do is we should probably go through an example of solving an equation using the quadratic formula. So let's say we have a quadratic equation, so we're going to solve 6x squared is equal to x plus 2. So the first thing I want you to notice is that this is a quadratic equation. However, this is not a quadratic equation that's in standard form. Now, in order to use the quadratic formula, we need to make sure that our quadratic equation is in standard form. Again, that would be ax squared plus bx plus c equals to 0. So the first thing that we need to do is place this quadratic equation into standard form. And that's going to involve taking these two terms, the x and the plus 2, and bringing them over to the left side. And then the right side is going to have a 0 left over. So what that's going to look like is we're going to have 6x squared, we'll have minus x, minus 2, and we'll still have equals to 0 on the right side. Now, if you compare this to what we have up top, ax squared plus bx plus c is equal to 0, this does look like that format. So when we have this written in standard form like this, we should be able to identify the a value, the b value, and the c value. So in this case, we have a is equal to, well, we're asking ourselves what's the coefficient of the x squared term, and that's going to be 6 in this case. What's our b value? Well, the b value should be the coefficient of the x term. Now I want you to notice that our x term, we have negative x. Well, that means that the coefficient of the x term is just going to be negative 1. So we're going to have b is equal to negative 1. Okay, now for our c value. Well, the c value is just going to be, well, essentially the value of the term that doesn't have an x with it. So in this case, it's going to be negative 2. So that means we're going to have c is equal to negative 2. Okay, great. So the next thing we're going to do is we're going to write out the entire quadratic formula again. So that's going to give us x is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so now what we're going to do is we're going to take these a, b, and c values, and we're going to plug them into the quadratic formula in the proper spots. Okay, so let's see, what's that going to give us? Well, the first portion of our quadratic formula says we're going to do negative b. So we're going to put down the negative, and we're going to ask ourselves, what is our b value? Well, our b value is negative 1. So we're going to be taking the negative of negative 1. Okay, now we're going to have our plus or minus. We're going to do our square root of b squared. Well, again, our b value is negative 1, so I'm going to have negative 1 squared. Right, we're going to have minus 4 times a times c. So it's going to be negative 4 times our a value, which is 6, times our c value, which is negative 2. Okay, so underneath the square root, we've got negative 1 squared minus 4 times 6 times negative 2. And this whole thing has to be divided by 2 times our a value, which is 6. So we've substituted our a, b, and c values into the quadratic formula, and from here on, the whole idea is that we need to simplify this expression. So that's what we're going to be doing for the rest of this question. Okay, so let's make ourselves some more room over here. All right, so we ask ourselves, what is the negative of negative 1? Well, when you're taking the negative of something, it's basically the same as swapping its sign. So if we swap the sign of negative 1, that's going to give us positive 1. We have our plus or minus. All right, we're going to have our square root of, well, negative 1 squared. What is that? Well, that's just positive 1. Okay, now for the next three parts that we have here, we have negative 4 times 6 times negative 2. I recommend multiplying those three together all in one step. So if we do negative 4 times 6 times negative 2, that is going to give us positive 48. So next to the 1, I'm going to put a plus 48. Okay, again, we got the 1 from negative 1 squared. We got the positive 48 by doing negative 4 times 6 times negative 2. Okay, and this whole thing is being divided by 2 times 6. Well, that's just going to be divided by 12 then. All right, so that looks a little simpler. Next thing we're gonna do is we're gonna deal with the stuff underneath the square root a little bit more. So we're gonna get 1 plus or minus the square root of, well, we had 1 plus 48, that's gonna be 49. Okay, and we're dividing that by 12. Okay, next thing we're gonna do is we're gonna fully evaluate the square root. So that's gonna give us 1 plus or minus, well, the square root of 49 is actually just 7. So we're gonna have 7, 1 plus or minus 7. And again, we're dividing the whole thing by 12. Okay, so now let me show you how to deal with this plus or minus business. Right, that's going to be the next thing we do. Now, when we have 1 plus or minus 7 divided by 12, basically that's just two different expressions written at the same time. We're going to have 1 plus 7 divided by 12, and then we're going to have 1 minus 7 divided by 12. And what we're going to do is we're going to take these two and we're going to separate them out and calculate them individually. So let me show you what I mean by that. Let's start with the 1 plus 7 divided by 12. We're going to take that over to the left side, and we're going to say x, because remember we are solving for x, we're trying to determine the solutions to the equation. X is going to be equal to 1 plus 7 divided by 12. So again, we took the plus with us, and we're going to leave the negative for the next one. Okay, well, we ask ourselves, what's 1 plus 7? Well, it's going to be 8, so we're going to have 8 over 12. Now, 8 over 12 is a fraction that we can simplify, and that's going to simplify to 2 over 3. And that means that x equals 2 over 3 is going to be a solution to the original equation we started with, which, let me remind you, was 6x squared is equal to x plus 2. And that means that if I were to take 2 over 3, and if I were to sub that in for x on the left side and the right side of my initial equation, I would end up getting the same number on the left side as on the right side. Okay, so let's deal with the 1 minus 7 divided by 12 now. All right, so we have x equals 1 minus 7 divided by 12. Well, we're going to evaluate 1 minus 7. That's just going to be negative 6. So we're going to have x is equal to negative 6 divided by 12. And negative 6 over 12 is also a fraction that could be simplified. And that's just going to give us negative 1 over 2. So that's the second solution to the equation. And that means that if I were to take negative 1/2, negative 1 over 2, and sub that into the left and right side of my original equation, I would get the same number on the left side as I would on the right side. So again, we could have solved this equation using the method of factoring, and we would have gotten the same answers. So some of you might be looking at this page and looking at all the different values that we have here and then this long formula and asking yourselves, well, why didn't we just factor to begin with? And again, we could have, right? But there's a reason why the quadratic formula is important. It's because some equations can only be solved using the quadratic formula. So let's do another example, and I'll show you what I mean by that. So we're going to solve x plus 1 is equal to x squared, and we're going to solve this to 3 decimal places. So this is going to be an example of an equation that if you tried to solve it using, say, factoring, you wouldn't be able to do it. So I'm going to get you guys to notice that, once again, this is not in standard form, right? In standard form, we need to have 0 on one side of the equal sign, and on the other side of the equal sign, right, we have all of our terms. So the first thing we're going to have to do here is we're going to have to move some terms over. I'm going to move the x and the 1 to the right side to go with the x squared. And that's going to leave me with 0 on the left side. So that means that we're going to have 0 is equal to x squared minus x minus 1. So this is now in standard form. Okay, so at this point, this would be the point where you'd want to pick a method. Maybe I'd want to factor, maybe I'd want to use the quadratic formula. So what you could do is, if you want, maybe pause here for a second and take a look to see if you can factor this. And you should notice that it can't be factored. Okay, so what we're going to do is we're going to use the quadratic formula then. And in order to use the quadratic formula, right, we're going to have to identify a, b, and c values. So what I'm going to do is I'm going to write out the quadratic formula first, and now let's identify our a, b, and c values. Okay, well again, a is going to be the coefficient of the x squared term. Now notice that there's no number directly in front of the x squared term, and of course that means that the coefficient of x squared is just going to be positive 1. Okay, next is going to be our b value. B is going to be the coefficient of the x term. Well, notice that we have negative x. Again, that means that our coefficient of the x term is going to be negative 1. And our c term, well, that's going to be the term that doesn't have an x, and that in this case is going to be negative 1. So again, the next step in using the quadratic formula is going to be to sub these values into the quadratic formula. Okay, great. So that's going to give us the negative of our b value. So we're going to be taking the negative of negative 1. We're going to do plus or minus the square root of b squared, which in this case, again, our b is negative 1, so we're going to be squaring negative 1. Then we're going to have negative 4 times our a value, which is 1, times our c value, which is negative 1 as well. And this whole thing is going to be divided by 2 times our a value. Well, that's just going to be 2 times 1 then. Okay, so now we have to evaluate this, now that we've subbed everything in. Okay, let's start with the negative of negative 1, which is positive 1. Then we're going to have plus or minus the square root of. And once again, underneath the square root, I really recommend separating it into kind of 2 pieces. I recommend squaring the b value and then multiplying the negative 4 with the a and the c values. So let's start by squaring the b value. Well, negative 1 squared is going to be positive 1. And then we're going to do negative 4 times our a value times our c value. That's negative 4 times 1 times negative 1. And that's just going to be positive 4. So that means we're going to put plus 4. And this whole thing is going to be divided by 2 times 1, which of course is just 2. Okay, so underneath our square root, we can still evaluate 1 plus 4. So that's going to give us 1 plus or minus the square root of, well, 1 plus 4 is 5 divided by 2. Okay, great. So now what we're going to be doing is we're going to be taking the square root of 5. Okay, so let's see here. We're gonna have 1 plus or minus. Okay, now here's the thing. The square root of 5, if you take a calculator and you calculate the square root of 5, you're gonna notice that it's not gonna give us a nice number. It's gonna give us a long decimal number. Okay, and that means that in order to do this, we're gonna have to do some rounding. So in this is a scenario where we're not finding the exact solutions to the equation. We're gonna be finding the approximate solutions to the equation. And if you remember, the initial question asked us to solve to 3 decimal places. Okay, great. So let's see here. What I recommend doing is if we're solving to 3 decimal places, we're going to be stating the final answer is 3 decimal places, but I think that every step before the final step, we should maybe include 4 decimal places, right, just to make sure that we don't have any rounding errors. So we're going to calculate the square root of 5 to 4 decimal places. Now, by the way, since we're doing an approximate value, we're going to have to make an adjustment here, right? So by the way, the square root of 5 is 2.2361 to 4 decimal places, since our final answer is going to be 3 decimal places. But since we're having to round, what I'm going to be doing is I'm going to be putting a dot above my equal sign to indicate that we are doing an approximate solution. And of course, we need to take this and we need to divide by 2. Just going to remind you, though, that we rounded the square root of 5 to 4 decimal places, because our final answer is going to be 3 decimal places, and we're trying to avoid a rounding error. Okay, so this is the step where we're going to split this into 2 pieces. One's going to take the plus with it, the other one's going to take the minus with it. All right, so let's deal with the plus first. So we're going to have x is approximately equal to, we're going to have 1 plus 2.2361 divided by 2. Well, 1 plus 2.2361 is going to be 3.2361, so we're going to be dividing that by 2. And that's going to give us x is approximately equal to 1.618. So that is an approximate solution to the original equation. Now, because this is an approximate solution, if you were to take 1.618, sub it into the left side of the original equation that we were dealing with, and sub it into the right side of the original equation we were dealing with, you would not get exactly the same number, but you would get something very, very close to the same number. So, for example, if I took 1.618 and subbed it in for x plus 1, which is the left side of my equation, well, I'd have 1.68 plus 1, that would give us about 2.618. All right, if I subbed 1.618 into the right side, so if I sub that in for x squared, right, well, that is going to give me something approximately close to 2.618. So they're not going to be exactly the same, but they will be very, very close. Okay, so let's get the other solution. So this is going to be where we're going to take the minus. So we're going to have x is approximately equal to 1 minus 2.2361 divided by 2. Okay, 1 minus 2.2361, well, that's going to give us negative 1.2361 divided by 2. All right, and then calculating this, we're going to get x is approximately equal to negative 0.618. I'm going to remind you guys that, yes, my final answers are with 3 decimal places, right? But the steps before it used 4 decimal places. Either way, these are the 2 approximate solutions to the equation that we dealt with. And yeah, we were not going to be able to get these solutions using the method of factoring, so we were sort of forced to use the quadratic formula here. All right? So this is why the quadratic formula is important. Right? The quadratic formula is going to allow us to solve any quadratic equation that has solutions. Okay, so what we're going to do is we're going to do one more example. All right? Slightly different example. So for our next example, we are going to determine the x-intercepts of the function f of x is equal to negative 2x squared plus 3x plus 4. So we have a quadratic function, and we want to find the x-intercepts of this quadratic function. Okay, so I'm going to remind you that a quadratic function and a quadratic equation are not really the same thing. A quadratic equation has solutions, right? A quadratic function has a graph, okay? So I could graph f of x equals to negative 2x squared plus 3x plus 4. All right, so what does this have to do with solving quadratic equations and using the quadratic formula? Well, I'm going to remind you that the first step of finding the x-intercepts of a quadratic function is to substitute 0 in for our y value. The reason why is x-intercepts occur on the x-axis, and we know that on the x-axis, any point has a y value of 0. So the first thing we're going to do is we're going to sub 0 in for y, which in this case is represented by f of x. So that means that we're going to have 0 is equal to negative 2x squared plus 3x plus 4. And take a look at this. This looks like a quadratic equation now. So we should be able to solve this using the methods that we've discussed. So again, it could be either factoring or the quadratic formula or whatever. Now, in this case, this is going to be another example where factoring is not going to work. So the only way to properly determine the x-intercepts of the quadratic function we have here is going to be to use the quadratic formula. All right, so first thing we need to do when we're solving a quadratic equation is we need to make sure it's in the proper form. Well, notice that we don't actually have to move any terms around in this case. All of the terms are on one side of the equal sign, and the other side just has a 0. So we don't need to move anything. We're good. So what we could do is we could jump right to identifying our a, b, and c values. Okay, so in this case, a, which is the coefficient of our x squared term, is going to be negative 2. b is going to be the coefficient of our x term, and that's going to be positive 3. And c is going to be the term without an x. Well, it's going to be positive 4. So now we're going to write out our quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac divided by 2a. And we're going to sub these values into the quadratic formula. Okay, great. So that's going to give us the negative of our b value. Well, our b value is 3. So the negative of 3 plus or minus the square root of our b value squared, so that'd be 3 squared, minus 4 times our a value, which is negative 2, times our c value, which is positive 4, divided by 2 times our a value, which is negative 2. So now we just have to simplify this. All right, starting with the first part, we have the negative of 3. Well, that's going to be negative 3, of course, plus or minus the square root of. Again, I recommend doing the stuff underneath the square root in kind of 2 pieces. I recommend squaring the b first, so that'd be 3 squared, which is 9. And then I recommend taking the negative 4, multiplying by the a value, multiplying by the c value. So we do negative 4 times negative 2 times positive 4, and that's going to give us positive 32, so I put 9 plus 32. And we're dividing by 2 times negative 2, well, that's just negative 4, so dividing by negative 4. Next, underneath our square root, we've got 9 plus 32. Well, that's going to be just 41, so our next line is going to be negative 3 plus or minus the square root of 41 divided by negative 4. Okay, and now we have to deal with the square root of 41. Now, the square root of 41 is going to be another one of those cases where we're not going to get a nice whole number or a fraction or anything like that. We're going to have to do some rounding. Now, I think that because we're determining the x-intercepts of this function, maybe we would be determining the x-intercepts of the function in order to sketch it. So I'm kind of thinking that for our final answer here, maybe we could round our final answer to 1 decimal place, because 1 decimal place is usually pretty good for a sketch, right? Using 2 or 3 decimal places is a little bit too many for like drawing a sketch of a graph. So we're going to round our final answer to 1 decimal place in this case. And that means that I'd kind of like to do 2 decimal places for all the steps before our final step. So let's see, we're going to do -3. Notice that I put the dot over the equal sign because we're going to be doing an approximate answer. -3 plus or minus the square root of 41, which is about 6.40. Again, we're doing 2 decimal places for now and then 1 decimal place for our final answer. And we're going to be dividing that by -4. Okay, so let's split this into 2 pieces now. All right, so for our top piece, I'm actually going to take the negative this time. It doesn't matter whether you take the negative or the positive first. I'm going to take the negative. That's going to give us -3 minus 6.40 divided by -4. Dealing with the top, we're going to have -3 minus -6.40, which is -9.40 divided by -4. Okay, and then dividing these, we end up getting x is approximately equal to 2.4, which I'm going to round to 1 decimal place. Okay, great. Next, we're going to take the plus, and that's going to give us x is approximately equal to -3 plus 6.40 divided by -4. Adding the 2 terms in the top together, we're going to get positive 3.40, which we're then going to be dividing by -4. All right, so dividing those, we end up getting x is approximately equal to -0.9. So again, these would be the x-intercepts, the approximate x-intercepts in case maybe we were trying to graph them. All right, and actually, we do have x equals or approximately equal to 2.4 and x approximately equals to -0.9, but what we could also do is we could state this as a pair of coordinates. So we could state that, therefore, the x-intercepts are at approximately 2.4 and 0 and -0.9 and 0. Okay, so that's been 3 examples of how to use the quadratic formula and some of the details in the actual process. I hope it's been helpful for you guys. Take care.